Sorry guys, I was just fixing my microphone there. What is up? Welcome back. I believe today is episode 163. Man, we've come a long way. Gotta fix my hair here, dude. Getting crazy. But yeah, come a long way. Episode 163.
What is up? Welcome back.
Whoops, guys. Sorry, my bad. But yeah, we're gonna jump into some problems today. Excited to see what we're gonna work on. It's gonna kind of set up my workstation here. How do we do this? Okay, let's go over here. Move this over here. Let's pull up Xgalley Draw. Think about some problems. Take a look at our problem today. I believe we're going to look at word search, I think, from memory, what it was yesterday. Which was yesterday's problem of the day. Which I believe goes back one. Yeah, this one here, it's an easy problem. Gonna do a little bit of both, I think. Let's see here. We'll start off with a Python. Okay, so we're looking for a valid word. That's what our problem is called. Valid word. This is yesterday's daily problem. So let's take a look. Okay. So let's see here. A word is considered valid if it contains a minimum of 3 characters. It contains only digits 0 to 9 and English letters uppercase and lowercase. It includes at least one vowel. And it includes at least one consonant. What is a consonant? I have no idea what this is. I don't know if I should know. Or a basic speech sound in which the breath is at least partly obstructed. What the... A B, C, D. So maybe it needs to include at least one of these as A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, V. Okay, so we're missing a couple there in the alphabet. Okay, so you're given a string word. Return true if a word is valid, otherwise return false. A, E, I, U in the uppercases are vowels. A consonant is an English letter that is not a vowel. Okay. I didn't know that. That's interesting. I don't know why this has a 50% acceptance rate. I feel like there's probably something that I'm missing here. It contains a minimum of at least 3 characters. It contains only digits 0 to 9 in English letters, uppercase and lowercase. Okay. It includes at least one vowel. One consonant, right? So this here we return true. We return false here because we need a minimum of 3 characters. We only get 2. Fewer than 3 does not have a vowel. False. This word contains $ character and does not have a consonant. Okay. I mean, okay. So let's take a valid word, right? Put this here. Take the input of our word. What do we want to do, right? So how are we going to be able to do this? Well, we need some sort of count here, right? Contains a minimum of 3 characters. We can't really take the length, right? Because the length won't give us a valid minimum of 3 characters, right? Because we could have a $, right? I don't think that counts as a character. Or does it? I don't know. Then it would be technically be incorrect if it is has a $sign anyway. So can it be... Okay. So I'm not sure, but I guess we'll just assume that we can't take the length, right? We can have duplicates, right? Which is pretty obvious. We can have duplicates. We need a minimum of 3 characters. So really what I'm thinking here is that we, have I think we're going to have 2 dictionaries, right? 2 dicks. One for vowels, right? And then the other for consonants. Right? We have vowels and consonants. What I'm thinking here is that whenever we see one of these, what's up? What's up, Galactic dude? Nice to see you, bro. I didn't see you yesterday, bro. Were you in the stream yesterday, bro? I don't know if I remember. I don't think I remembered your name. Maybe. Keep grinding, bro. Thank you, dude. Appreciate it. Thank you, thank you, Shams. But yeah. So I'm thinking we have 2 dictionaries, right? Vowels and consonants. We loop through these, right? If we see there's a valid character, we can increase our characters by 1, right? Right, we would increase a character by 1, which would loop through that. We'll get our characters, right? Yeah, I missed yesterday's stream. Had some stuff to take care of. Yeah, dude, I understand, bro. It's all good. I get it, bro. Shit happens, dude. Yeah, let's put on some, some lo-fi or something, bro.
I'm not underdogging my way through this anymore. I got firepower now. See, I used to feel like I was drowning.
Okay. So I think that'll take care of our minimum. It contains only digits and English letters. So we'd obviously need a dictionary as well. I think we'll need 3 dictionaries then. 3 dictionaries being vowels, consonants, and numbers. Again, there's probably multiple different ways to do this, but I'm just going to say we can have a numbers too. Which means we have all these. We'd be able to count the minimum number of characters. If we see a symbol that's not in either of these dictionaries, then we must know that it's an invalid character, which means we'd instantly return false. Hope you get it, the job. Thank you, Shiram. Thank you, bro. Appreciate it. So obviously here we'd instantly return false, right? If we see, hang on, let's put that in a different color. Return false. Return false, right? If we see a character that's not in any of these, right? So, let's generate a generate a dictionary with all vowels, upper and lowercase. Got AI to generate us this dictionary right here. Didn't want to type this manually myself. In this case here, I feel like maybe this could be a hash set, couldn't it? I mean, probably can. I feel like a hash set would work as well. Now that I think about it. I think a hash set would work here. We can call it val hashy. Right, we can also have a consonant hashy. Upper and lowercase. Then we can have a consonant one, right? Holy shit, this is... What is going on here, man? Oh my gosh, I'm just gonna leave it. We can have our consonant hashy. Right? And then we can also have our number hashy. Then we have our digits here, right? Let's do a... Let's call it num hashy. Here we have our num hashy here. I think we're fine here, right? Yeah. That looks totally fine. Okay. Anyway. Okay. So now we have all our hashes, right? Either use dictionary or a hash set. I think a hash set would work here totally fine. We've got our numbers, we've got our vowels, and we've got our consonants, right? So now I feel like we can just do a simple loop here, right? We can do, well, for char in word, we can do, okay, well, if char in vowel hashy, and, I'm sorry, or char in consonant hashy, or it's in our num hashy, right? Then we can probably want some sort of res, right, to return. We can increase our res by 1 and have an else here. Else, if it's not in this, we can instantly return false, right? Then we can return our res if res is greater than or equal to, sorry, return true if res is greater than or equal to, greater than or equal to 3, else false. Let's see how I thought about this. Okay, this we didn't pass here. We got you outputted true. Or char in constant hashy, or or char in num hashy. Else we return false. There we go. I think this should submit. Nope. Missing something. Okay, so what is wrong here? We're getting 3 PP and we're returning. Output is true, expected is false. Okay. What is going on here? True, false, 3 PP. Output true, expected false. Is 3 not... Let's get about if we see 3 characters. Okay. We see 3 characters. So I think we have to distinguish the difference between the characters and the nums, so we'll have to split up this if statement here. Okay, so we got our nums here, so I think a character would either be one of these two, right? So guess we can simply fix this by just getting rid of this. Right, having an else if here. Char in numhashi. We can just continue. Otherwise, we would just return false. I think that should work. I feel like this is a pretty shitty way of doing it, but I think this should work now. Nope. HSQ expected false, but we're returning true. We have a minimum of 3. Why is that? It contains a minimum of 3 characters. We have 3 characters here. So case 5 here, HSQ. It includes at least 1 consonant. Ah, okay. It includes at least 1 vowel. We're not actually checking this here. So we'll have to check. Okay, well, we come in here. I think we're gonna need some flags here too. So we're gonna have to do. Okay, well, it does not contain a vowel. Yeah, I noticed that. Thank you, Eduardo. We have to figure out how we want to do that. I'm thinking of. We can have vowel flag is equal to false. Consonant flag is equal to false. Right? We can check down here. Well, if we see a vowel hashi or we see a consonant hashi, we can check, well, if vowel flag is equal to false, I guess we can just do if not vowel flag. If not vowel flag, we can make vowel flag equal to true. Why not use ASCII values? Honestly, dude, I probably could. Right now, my literally first intuition was to use separate hash sets, so I just kind of went with it. I know there's a bunch of other ways that you could possibly do this, but I'm not specifically looking for probably the most optimal way or the, you know, most epic way to do it. I'm just kind of looking to solve a problem. That's my goal. So you can always optimize it later. We make this true. We increase our res by 1. And then we return true if res is greater than or equal to 3. And vowel flag and consonant flag. Can you do this in Python? Can you have a I don't know if you can do this in Python. I have no idea. If not vowel flag is equal to true, consonant flag is equal to true. I'm gonna check if you can do this in Python. I don't know if this is possible, to be honest. Okay, so that is valid. Okay. So why? Let's print out. Since we don't have a debugger, let's print out vowel flag and print out consonant flag. Let's see what it is over here. The end. We're getting both true. Check the word length first. See, I was thinking about checking the word length, bro, but like I think the word length won't work because we can't have characters that. I guess we could check it the opposite way, right? We could only count special characters, and if there is special characters, we can take that off the length. I don't know. Again, you know, there's many better ways that you can do this. I literally just did the first thing that came in my head. This looks super sloppy, the code, but it's like, I don't know, it's whatever. Expected false. But what are we getting? We're outputting true. Oh shit, this is not working. We're checking both here. Okay, maybe we're gonna have to make these separate, I think. So we'll have to make this separate. Else if if not val flag, we make it true. Res plus or equal to 1. If not, constant and hashy, we make it true. We want to increment our res. Shit, I have 2, dude. What is going on here? Whoops, dude. Didn't mean to do that. Example 3, the word length would pass, but since there is a special character, it's not a word. Yeah, exactly. Thank you for that, Eduardo. You know, again, like what I said 5 minutes ago, you know, I probably could have checked this in an opposite way. You know, I probably could have, you know, taken the word length and then looked for special characters. Now that I think about it, probably a better way. Taking the word length, look for special characters, and minus it from the length of it. But, I don't know. Again, it's all just like what I was thinking on the spot. So, okay, so now I'm getting, what am I getting true here? 2, 3, 4, 8s. Why is this? We're expecting true, but I'm getting false. Oh, whoops, I have val flag here. This is meant to be consonant flag. Consonant flag. So we do if char and val hashy, if not val flag. Also if char and constant hashy, if not consonant hashy. Res plus or equal to 1. Get Linux, trust. I do have Linux, bro. I dual boot Linux. I'm on my Windows boot right now because I like to do some problems in C++, and I need Visual Studio to do it on Windows, bro. Well, what distro you use, mister? You could evaluate each condition one by one. I could. That is true. If all the conditions are true, then true. Yeah, that is true. I could. Let me just see if this works. Consonant flag. Charting, I'm actually. Okay, wait. Let me just see what I'm looking at here. Oh, dude, this problem is so AIDS, dude. Oh my god. Ubuntu user here, dude. Ubuntu. Let's go, man. I use Linux Mint. I'm sure. Maybe you've seen it before, but I was using it yesterday, but 2, 3, 4, 8s. So what are we getting here? We're getting true. We're getting false. We're getting false on our constant flag, but it should be true, right? Because we see a D here. Else if char in consonant hashy, which it is. If not constant hashy, we make the consonant flag true. Okay. Res plus or equal to 1. Why is this not working though? Why are we getting false here, bro? We should see it here. Anyone know why this is not working here, dude? I don't think I'm seeing why this is not passing. Why I'm getting false here. Spelling consonant hashy, right? I would have got an error if this was wrong. Oh my god, I'm checking not the flag here, dude. That's why. Consonant flag. That's why. Jesus, dude. It's so hard to see sometimes, bro. Oh my gosh, dude. Okay, so now we got another one that we failed. I can see why it's a 50% pass rate. One last edge case that we're missing here. What are we missing? 22ANN. Why does this fail? It includes a minimum of 3 characters. See, I don't know if this is failing because... Is this 4 characters or does the character include only these 2? And these are technically numbers. I don't know. I have no idea. But... we've got a vowel, right? And we have a consonant. So this should be true. This is correct. Else if char and num hashi, we continue. So maybe our reason why this is failing is because obviously we're not reaching our character amount. We're not getting to 2. So that means I think numbers must be okay. So we probably should increase for a number. But will this fail? Other test cases? I don't know. Nope. Looks like we're good. Are we gonna pass here finally? Okay, there we go. Pass, bro. Pass with flying colors. We were the fastest solution. Wow, interesting. So I was thinking about the right way. I mean, I could have done stuff much better. I probably could have simplified the code much easier. But you know what, dude? At the end of the day, you solve the problem. That's all that matters. You just gotta solve the problem, bro. I feel like that's the most important thing. Anyway, okay. So that was yesterday's daily problem. Catching up on some of the days that I missed when I was out for my birthday with family and stuff. So anyway, let's jump into another problem. Let's take a look here. I'm gonna shout out this website. Shout out to Galactic for giving me this website. If no one's ever seen it before, you can take a look at like rating level problems. So we're going to look at 1500 or 1600 level problems. We'll take a look at a 1500 level problem. I think we looked at this one. Weekly contest 3 of 4. 2022, dude. Yeah, bro. All these rewards everyone's getting, bro. How goated. Let's take a look at this problem here. Maximum number of groups. Shouldn't be too bad of a problem, hopefully, but I guess we got to think about it. So 2358, maximum number of groups entering a competition. They're given a positive integer array grades, which represents the grades of students in a university. You would like to enter all these students into a competition in ordered non-empty groups, such that the ordering meets the following conditions. The sum of the grades of the students in the ith group is less than the sum of the grades of the students in the i+1th group. Like, okay, so I have to read this a little slower because I have a slow brain. Sorry, I missed your message. Use Arch, by the way. Let's go, bro. Yeah, dude, I'm too scared of using Arch, dude. I don't know. I feel like all my shit's gonna break, dude. I'm not a Linux bro, dude. I just kind of wanted to try it out. I do like it, but I ain't a Linux pro at all. I'm pretty garbage at it, to be honest, but... Okay, let's read this slowly. You're given a positive integer array grades, which represents the grades of students in a university, right? And that's the only thing that we're given in this problem. We're just given grades. You would like to enter all these students into a competition in ordered, non-empty groups, such that the ordering meets the following conditions. The sum of the grades of students in the ith group is less than the sum of the grades of the students in the ith+1 group for all groups except the last. The total number of students in the ith group is less than the total number of students in the i+1th group. The number of students in the ith group is less than the total number of students in the i+1 group for all groups except the last. Return the maximum number of groups that can be formed. The maximum number of groups that can be formed. Okay. By the way, is this music a little loud, dude? I don't know. I don't know if this music is too loud or not. Well, let me know if it's too loud. I'll turn it down. But Okay. So let's paste over our input over here. Take a look. So given our grades, we want to, I assume what we want to do here, just as a kind of high-level explanation, is that I assume we probably want to split these up into specific lengths, right? Whatever, I'm not going to even look at the numbers, but, you know, for example, we get 6 here total. I'd be like, I believe that's our first one. The sum of the grades of students in the ith group is less than the sum of the grades of the students in the ith plus 1 group, right? So we take the ith group here. So this is be low. So really, like, we need something like 6, 6, right? The total here is 6. The total here is 15. Right, and let's say maybe we have another group here. I'm gonna move this one down here. Let's say we got like 4, 10, 10, 12, right? Our total here is 20, 24, 26, 36, right? So I believe this passes both our conditions. One, because we add the sum of them is greater, right? We got 6 here, then we have 15, and then we have 36. But also in our second one here is that the total number of students in the ith group is less than the total number of students. Oh wait, the total number of students in the ith group. Okay, no, that works. In the ith group is less than the total number of students in the I plus 1th group for all groups except the last. Okay, so I'm a little... Okay, so this would be wrong then, right? I was assuming that you see the length of our array here grows every time. So we have 3, 3 here, and then we have size. The length is 2, the length is 3, the length is 4. I feel like that was probably what we're going to need. But really, what's good is that the last group doesn't matter what it is, right? The last group can be, you know, it still has to be... I think it still has to be... Oh, except the last, right? So really the last doesn't matter, right? The last can be whatever. It can be greater than or it can be smaller. So really we could have like 1 here, or we could have like 100. You know, it doesn't really matter, right? So really the last group does not matter. Return the maximum number of groups that can be formed. So I think we understand the problem fully. A little bit of an interesting problem. So far, I'm not really getting any intuition for the problem. I don't really know kind of the way I want to solve this. The following is a possible way to form 3 groups of students. First group has students with grades 12. Sum of grades 12, student count is 1. Second group has the students with grades 6, 7. 6, 7 is greater than 12. I have a feeling that this is probably going to be some sort of greedy problem here. Not gonna lie. That's kind of the feeling I'm getting here, that this is definitely a greedy problem. Third group has the students with grades 10, 3, 5. Some of the grades 10, 3, 5, 18, student count 3. It can be shown that it is not possible to form more than 3 groups. So we return our maximum as 3. I have a feeling that we're going to have to sort our grades, right? That's the intuition I'm getting. That's the feeling I'm getting right now. I feel like it's going to be important to sort our grades. So this is the sorted version of our grades. We can make this orange, I guess. Really, we're working with these numbers here, right? Guess let's delete these lines. I don't really need these lines anymore, I guess. I'm gonna take a look at the topics. Okay, it is greedy, right? I was thinking about it, right? It is a greedy problem. We've got a binary search topic here too. Maybe some sort of modified binary search. I'm not the best with binary search problems. I really do struggle to think about them, so I don't think I'm gonna get the intuition for the binary search here. Let's see here. How do we want to think about this? What would be the greedy solution here? Well, maybe we can... Can we increase, right? No, I'm not sure. If anyone has any solution or has a hint for me, I'd appreciate it if you know how to solve it. Would it be easier to place students into valid groups after sorting them based on their grades in ascending order? Okay, well, I always feel like when I'm looking at a greedy problem, I'm always like, okay, fucking like, I literally said this last stream, I think. I'm like, 90% of the time, you got to sort the problem. Notice that after sorting, we can separate them into groups of size 1, and 2, and 3, and so on. If the last group is invalid, we merge it with the previous group. This creates the maximum number of groups because we always greedily form the smallest possible group. So what I'm thinking here is that... So the first group is always going to be of size 1, right? So we're always going to add 3 here, right? So that is going to be our first group. Then we start from here, we want a size 2, right? So let's say we get 11 here, right? 11 is greater than 3. So I guess that works, right? We would have 5, 6. Then we'd start from here, and we would do, okay, well, 7, 10, 12, we would add 3. 7, 10, 12, that would work, right? We would return our maximum of 3. I don't think it's that straightforward, though. If the last group is invalid, we just merge it. This creates the maximum number of groups because we always greedily form the smallest possible group. Okay, so if I in range length grades. What do we want to do here? How would we do this in terms of making these groups? Two, three. I feel like the solution is going to be very simple. I'm trying to think about the way that we would solve this. Trying to think here. Get our maximum groups here. So I'm thinking here what we want to do here is we want to have our group size here, right? So group size, start off at 1. We probably want to have a left at 0, right? We loop through for iron range length grades. How would we want to do this, right? So Maybe it would be a while instead. While left plus group size is less than or equal to the length of grades. So we do left 0 plus group size, the size that we're looking at, is less than or equal to the length of grades. Length of grades is 1 longer, so I believe we would do less than length grades. So we're looking at valid numbers every time, right? What will we do here? Well, maybe we need some sort of if to check, like our distance that we're looking at. This is a tricky problem, bro. I've never really kind of thought about it like this before. I've never really done this sort of looping with the while. Trying to think here. I plus equal to group size. Plus or equal to 1. 10 group size. Minus 1, because we're already 1 ahead. Let's take a look here. It's variable I. Whoops, this is meant to be left, not I. Ooh. So we're on while left plus equal. I think this is meant to be equal. No, I don't know. While left plus group size, right? So our group size is 1 here, right? Start off with group size of 1. Group size plus or equal to 1. Alright, so then our group size goes to 2. We go to the next iteration here. So our left is at 1, right? We go plus or equal, left plus or equal to group size. So now we're at 3. So now we're looking at here. Group size plus or equal to 1. Sorry, yeah. Then we add 3. Go to here. I think we need an equals here. I think that's why it's not working. There we go. Is that gonna pass? Okay. Wow. That was a very interesting problem. A weird problem for sure. We got the intuition, understood that it was a greedy. I feel like just struggling to come up with this definitely is tough. I feel like there's maybe some people here that are probably like, you know, oh man, that was pretty easy, but it's like, for me to come up with that was like very tough, and I really feel like for me, if I was under like time pressure and there was people watching me, I don't know if I'd be able to come up with that like on the spot. And it was hard to think about. But it worked. So we'll take it. So let's take a look at one more problem. Shit, dude. I need to make this a little bigger. Take a look at our problems. We'll jump into a study plan. I feel like doing these 1500 problems are good, but a lot of them are just greedy problems, dude. The past 3 problems I looked at are greedy problems, so I'm sure it'll change up, but I just want to take a look at a maybe a problem that we looked at before. Let's take a look at a backtracking problem. I don't know why, dude. I'm feeling a backtracking problem. Palindrome partitioning. Oh. I guess we solved this recently. Okay. Maybe not. Maybe we'll look at a DP problem. Which one though? Minimum path sum. Take a look at like a basic one. Man, are they like resetting my solutions at all, or what is going on here? 2 pointers. I do want to take a look at a dynamic programming problem, but I don't want to do something too difficult because I got stuff to do. Let's see if I can just. Is it gonna give me my solution? I'm gonna reset it really quick. Okay, I'll reset it. We're gonna do this. I didn't look at the problem. It's been a while since I've solved this. May 1st. Looks like we struggled a bit here too. So, maximum product subarray. So, given an integer array knowns, find a subarray that has the largest product and return the product. The test case is generated so that the answer will fit in a 32-bit integer. 2, 3, negative 2, 4. We're given 6. 2, 3 has the largest product, 6. Negative 2, 0, negative 1. The result cannot be 2 because negative 2, negative 1 is not a subarray. Okay, so let's go back here. Whoops. Oh shit, dude, what did I just do there? Okay, we move this here. Put this here. Okay. So really, what do we want to think about this problem? Well, we know it's a DP problem, right? So take a look here. It is a DP problem. So when I think about DP problems, I kind of like to think about the backtracking. Obviously, like brute force version of this first. Okay, so let's just kind of figure out exactly how we want to go about this problem, right? So we're looking here, we have 2, 3, negative 2, 4, right? What do we want to do here? Well, we want to look, let's zoom in a little bit. That won't work. Oh, Pirate Software versus Yanjo 1v1, who do you think would win? 1v1. 1v1, who do you think would win? Dude, I don't know, and I don't really care. To be honest. Pirate Software, bro. I don't know. Adam Lipson. Hey, what's up, dude? Good to see you, bro. How was your day, Adam? Thanks for stopping by, bro. So a subarray is a continuous non-empty sequence of elements within an array, right? So pretty much what we want to do is we want to look at our maximum product, right? So we want to go like this, right? 2, 3 has the largest product. In this case, 2, 3 has the largest product, right? Because we go here, 2, 3, 6, negative 2 is negative 12. Then we go back to 4, right? So we go like that. We jump to our next value. We go like this. Boom. 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 That's probably the way we want to go about it. So stretch out my legs, bro. Trying to think here. How would we want to solve this? Well, I feel like for starters, we're gonna need some sort of like, what are we looking for here? We're looking for the largest product, right? The product of subarray is guaranteed to be a 32-bit integer. Sometimes coming back to these problems, bro, are tough, dude. Like, I want to see, is this one rated? Maximum product subarray. Okay, this one's never been asked in a weekly competition, I guess, but I don't know. Sometimes I think these problems are definitely harder than like the one I just looked at. But who fucking knows, dude? I have no idea. Okay. To lock in a little bit. 2.3 has the largest product, 6. So what are we gonna need here, right? We probably want some sort of max variable, right? Max being the largest we've seen so far, right? Probably gonna loop through with a for loop, right? Going from the first value here, I would assume, right? Because we're probably gonna look at this value already, right? So we're gonna add on from where we're currently at. So that's why I'm saying we start from the first value here. So I'm gonna call this max num, right? And our max num so far, I'm just gonna leave it at, I guess this should be negative infinity, right? We can't leave it at 0 because we could have a negative max, I feel like. Potentially, I feel like that's a possibility. We could have a negative max. So I'm gonna set this to the float of negative infinity. Shit, how do you, I think it's like this actually. I'm gonna loop through for num in range length, range 1 to the length of nums. Damn, bro. Honestly, man, I'm not sure, dude. This is frustrating. May 1st, I did this on. I think I need a little bit of help, dude, low key. Should we take a look at Nico's video? Yeah, fuck it. Why not? Let's just take a look.
It's the final days for summer savings on Coursera Plus.
Sometimes you take the L, bro. Sometimes I can't do the problems that I've solved before. And I probably even spent hella time on this problem too.
And this is actually a dynamic programming problem, and I'm going to show you how to solve this problem easily. So we're given an integer arrays at least one number and has the largest product. So in this case, we have a 2, a 3, a -2, and a 4, and the largest continuous product we can make is 2 and 3, because 2 times 3 is 6. That is the largest product. We can't really make it bigger because there's a -2. If we multiply this by -2, it's going to be -12. That's not bigger than 6. So what's like your first idea how to solve this problem? Maybe brute force, right? Is there a brute force solution to this? Well, we want to find a subarray, right? So why don't we just try every single subarray? So let's say all subarrays starting at 2. We got 1 subarray, 2 subarrays, 3.
This is what we were thinking when I was showing it on my
right?
whiteboard here.
And for each of these, let's just calculate the product, right? Like the first one is 2, the next one is 2 times 3, the next one is 2 times 3 times -2, the last one is 2 times 3 times -2 times 4.
So this will be the
and
brute
we
force
end up
way,
saying that
right?
so far the biggest is this, but we're technically not done yet. All of these subarrays contain 2. So now let's look at all subarrays containing 3. So we got 1,
Obviously an
right?
N-squared
4.
solution here.
And basically the time complexity is big O n subarrays, and we see that the total number of elements we have is also n, right? It's n elements
Yeah,
in
we'll
the
get to the
array, so
optimal
we're going to get
solution.
n times n is n squared. So my question is, can we do better? And how can we do better? Maybe there's some patterns to this problem that we can use to our advantage to find a better solution than n squared. So let's look at one example. Do you notice anything about this subarray? Well, all elements are positive. So what does that end up doing? Like, this is all positive, so we got a 1. Okay, and next we want to check this subarray. Okay, multiply it by 2. We want to go even farther.
I feel like they're all
Check
positive
the
then.
3. Okay, multiply it by 3.
Probably just the
And
biggest-
what if we kept having
elements.
positive elements? 4, 5, multiply by 4, multiply by 5. Do you notice something? Up until this point, our product is going to be a 1. Up until this point, it's going to be a 2. Up until this point, it's going to be a 6. Up until this point, it's going to be a 24. Up until this point, it's going to be 120. If we have positive numbers, no matter what happens, they're going to keep increasing, right? So this is the simple case. If we get all positive numbers, then our product is always going to be increasing. So now let's actually look at the opposite scenario. What if we had all negative numbers? Because all positives is easy. You just multiply all of them and you get the max product. But with negative numbers, it's a lot more tricky. So let's look at the first number. So up until here, the max product is just -1. And then we add a second element, a -2. And then what do we get? We get -1 times -2. And we know that the product of that is 2, right? Positive 2. Now the last subarray we check from all the way from -1 to -3. So we introduce one more value, a -3. And now if we multiply all 3 of these numbers together, we see that our product actually got smaller. Now it's -6. And what's going to happen if we had another element over here? What if we had a -4? Then we multiply by -4, and now we see that our product is going to be 24. So you see that when you have negatives consecutively, the sign is alternating. So when you want the maximum, it makes it kind of tricky to have negatives. But we also see that even though we got a -6 over here, there's actually a subarray that has a better solution. If you just take these two numbers, -2 times -3, we get a +6.
Okay, bro,
So
let's get to the
why did we
point.
get a
Let's get to the point.
-6 over here? How can we find the real maximum, which is +6? So even though we're looking for the max product subarray, we're actually also going to need to keep track of the minimum as well, and I'm going to show you why. So first, do you at least agree with me that if we want to find the max product array subarray of this, of the entire thing, it might be helpful for us to at least solve the sub problem, which is the max product subarray of just the first 2 elements first, and then use that to get the entire one. Okay, that makes sense. We know that the max product subarray of this is 2. Now, if we had a +3 over here, then we would say, okay, if I can get the max subarray of the first two elements and multiply it by 3, I'm going to get 2 times 3. It works when these are positive numbers, but we actually have a negative 3 over here. So I'm going to say get the max product subarray, which is positive 2, but let's also get the minimum product subarray of these two as well. And what do we know about the minimum? What's the minimum product subarray of these two? It's going to be negative 2. So I'm going to keep track of...
Oh, before you
dude,
leave, can
add,
you turn
bro.
that document into a PDF for me? Thanks.
both positive and negative. So we have a positive 2 and a negative 2. We keep the max and we keep the minimum. So now when we want to compute the max product subarray, when we include this 3, then we can compute that. We can compute that using both of these values. So we know that when we take the maximum 2, we get negative 3 times 2, which is negative 6. And we know when we take...
Okay, wait. We're gonna need a current min, current max, probably a global max, right? They're all gonna be num0, right? We have a for loop here.
The minimum we get negative 3 times negative 2, and that gives us a result of positive 6. So we know the maximum is positive 6 and the minimum is negative 6. So we take positive 6 and put it over here, and we can take negative 6 and put it over here. And hypothetically,
so really
maybe we get another element, and this time,
part of this
and this
problem, I
time
think,
whether
is
it's
the
positive or negative, right? So
taking
in this case, let's say it's
maximum
negative
and the
4,
minimum.
we will be able to find the solution because the minimum, or rather, we're looking for the max product subarray, and we know if we take negative 4, multiply it by the current minimum, which is a negative number, negative 6, we will end up getting 24, which is what we're looking for. But if you reverse it, what if we had a positive 4 here instead? Well, in that case, we can say, okay, positive 4 multiplied by our maximum, right? Our maximum, which is positive 6. So 4 times positive 6, we get 24. We still get it, right? So this, if we maintain the maximum and the minimum, we have all the information we need as we...
is equal to min. What we do here, min. Let's do like is equal to nums I. Let's make it easier. Put num. Oh no, we don't. Let's just fuck it. We don't even need this line. Let's just do nums I. Nums I. So we're taking the minimum here, right? To get the minimum of this value, we do nums I times our current min times equals our current min. Let's actually swap it over here. Times equals nums I. We take our current max to be our max of min. Sorry, not min, max. Max times equals nums I. And then obviously we need our global max here, right? And our global max would be the max of global max min. Sorry, max. What am I doing? We would return our global max. Is that really it? There's no way, right? Valid syntax. This doesn't have to be num. Whoops. why we're getting that. Nope. What are we getting here? Invalid syntax still. Times it equals min. Invalid syntax. Why is this invalid syntax? Is there a times equals in Python? I guess we don't even need to do times equals, bro. Maybe it could be that. We can just do times. I guess we're technically just comparing. Oh shit, whoops. We're missing something here. What did he say in the video?
We continue to add more elements to our array. So now let's just look at one edge case. So we're talking about positive numbers and negative numbers, but we know that one last edge case exists, the dreaded 0 value, right? So what if we had a 0 value and then maybe some other numbers, 3, 5, our 0 is gonna kind of kill us, right? It's gonna kill our streak. Like, look what's gonna happen to our min and max. If we take 6 multiplied by 0, we get 0. If we write 0 and making it a product of maybe 3 and 5, it's gonna continue being 0, right? Because any number times 0 is gonna be 0. So I'm gonna decide to handle this in
Ryan Miller invests
Another
the way
ad,
he
bro.
wants to invest.
Ryan sets his investments to automatic.
That was easier than I thought.
a different way. Our max at our minimum 0. When we get a 0 value, I'm gonna reset our max to 0, or rather to 1, and I'm also gonna reset our minimum to 1. And the reason I'm gonna do this is because I don't want to kill our and the new values like 1 is like a neutral, and I reset. Let's code it out. I'm gonna say our result with temp. So this way we're all.
Oh my gosh, dude. What does he do here? Max nums. Res is equal to max nums. Come in. I don't think I followed this video last time, bro. Can't do times equals like that. Yeah. Thank you, Adam. I just realized that. Thank you, bro. Frustrating, dude. What are we missing here, dude? So they're starting from 0 anyway. I don't think it really matters. I'm not sure what I'm missing here, dude. I don't know. What's happening here? We did, what the hell did we do here? DP max, DP min. Bro, what the fuck? What an interesting solution I did here. Is this a top down? Dude, I can never remember what they are. So we did the same thing. DP max 0 is equal to num 0, DP min 0 is equal to num 0, total val is equal to num 0. We loop. DP max is equal to num, DP max I minus 1 times num. TV min I minus 1 times num. I feel like we can probably solve it this way. Let's see. You do not consider swapping kermin and kermax when num's num is negative and you're not seeing kermin. So really, what we missed here is we have to deal with, we have to swap our numbers here. Kermax is equal to kermax, kermin. But why would we swap here, bro? Is everything else right? I think so. Was that really our issue, bro? Just that? Nope. What am I missing here? I arrange 1 to link nums if num is less than 0. Kermin, kermax. Kermax, kermin. So apparently here we're comparing nums I. Is that our issue? Is that what we're missing here? Oh shit, dude. Must be nums num. For some reason my neck is itchy as fuck. Okay, so that was our issue, but why? Oh shit, dude. Whoops. Nums num. Okay, let's step through this because I kind of want to learn why it's doing it like this. Spend a couple minutes on it. Bro, why doesn't it delete everything? Okay. So we're given our C-min. I just want to make sure I fully understand this. C-min, we're given 2, right? Which is our first value here, right? We'll do our C-max is equal to 2. And now we'll call our G-max, global max, is equal to 2, right? We loop through starting from our first value here. We check, okay, well, if nums is less than 0, if num is less than 0, shouldn't this... That works, bro? Yeah, I just want to make sure this submits before we... I just realized that, dude, here. Okay, that was our issue. Okay, right. I was tripping. Okay. Okay, so we check. Okay, is this number less than 0? No, it's not. Then we just take our kermin, right? We're looking at our current value, 3. Nums or kermin times nums num. So kermin, which is 2 times 3. So really, we're going to work with 2 for C-min. We're going to get a new max, though. And our new max is going to be 2 times 3, which is 6. Alright, we're going to actually think about... We're going to switch colors every iteration. So we're looking at this one. We're going to leave it at 2. This is now going to be 6. And then our kermax is going to be... Our global max and our kermax, which is going to be 6 as well. Right? Oh, Squiville, hey, what's up, dude? How you doing, bro? How's your day, man? Thanks for dropping by. coming to hang out on the stream, dude. Thank you, dude. We're giving 6 here. Okay. Then what are we? We go on next value, right? So really what we're doing here is we're taking kind of like a prefix sum sort of thing, I think, here. So for num 1 through, I don't know how I didn't think about that in the beginning, dude. How that didn't come into my mind. Sometimes this stuff just like, it's so frustrating when it doesn't come, but I mean, it's whatever. Okay, so let's go to our next point, right? So we're looking at -2 now, right? So our num is less than 0, right? Why are you doing Leetcode instead of real projects, bro? Z? I'm alright, bro. How are you? Why do I do Leetcode instead of projects? I do both. I just feel like, I don't know. I feel like Leetcode can, yeah, probably only get you so far, but I just like to, it's just easy for me. It's easy for me to stream Leetcode because, you know, people can jump in the stream and they can kind of look at the problem and they can see what's going on. And kind of follow along pretty quick. But instead, if I'm working on a real project, you know, I don't know. I just feel like there's not many people probably know what's going on, and you know, it's just pretty much the answer is that it's easy to do on stream. Oh, all right, I see. Yeah, I do both. I work on projects and I do Leetcode, but I do my projects like off stream. I also like to be a little bit more locked in when I'm doing my projects, just because, like, you know, most of the time I don't really know what I'm doing when I'm working on the project, so I'm kind of learning myself. And yeah, it's just a little easier to do this on stream than anything else. So yeah. And also I just feel like doing an hour of Leetcode every day can help too. I'm trying to figure out here why we swap co-min, co-max. Why do we swap here, dude? I can't remember why. What sort of projects are you working on, OS Quiville? Are you a student or? So we're swapping here because a negative, the most minimum number can also become the most maximum number for the update. I'm like scholar. Haha. What do you mean by that, bro? I'm in 11th grade now. Oh shit, dude, you're high school, bro. Oh fuck. Fair enough, dude. Pro code, actual projects don't do stupid problems like this. Yes, yes, Andre, I know. Stupid problems. I agree, bro. I agree, don't worry. I do work on projects, bro. Yes, Andre, I do work on projects, dude. I do them off stream though. It's just easier just to record streams doing Leetcode, so that's what I do. So appreciate the comments though. I want to learn Python, but I don't know how to or where to start. Got any tips? So just watch some YouTube videos, bro. That's all I would. If you want to, or just do boot.dev, dude, or do boot.dev's a good one. Just start doing problems like this on Leetcode, bro. I only picked up Python from Leetcode, literally. I haven't even made a real project in Python. I mean, I made little simple like apps and stuff like that in Python, but not like anything crazy. Remain Andre, shut up. Yeah, Andre, I do work on projects, bro, so don't worry. It's you know, I mean, I probably know most of C++ features, and I'm doing like, fair enough, dude. Yeah, I'm learning C++. I'm learning too. So, but yeah, just heads up to everyone. I do work on projects. I do a bit of everything. You know, I feel like a balance of everything is important. You know, and I do agree with what Andre's saying. It is, these problems are bullshit. You know, it's whatever. But I was gonna learn C++, but Rust has been a lot more fun. That's good, bro. I've never really looked at Rust stuff. What projects? What projects? Let me see. I've worked on a bit of everything, bro. I've made a lot of like full stack web apps. Right now, the current project I'm working on off stream is I'm working on learning C++. So I'm spending most of my time working on C++ so I can help my friend. I want to help my friend commit towards his game engine that he's building. And so I've been spending hours and hours off stream learning C++. So that's my goal right now. But I've built like multiple different projects. I've built a lot of web apps. Currently, I can't find anything interesting. You should start playing with OpenNGL. Yeah, I will. That is a plan, bro. That is a plan. Stuff I've done in the past. I've done a lot of web app stuff in the past. You know, right now I'm at my internship. I'm building like a support chatbot application that uses their company, their company knowledge base. It's got like an authentication system, like role-based users and everything. It's got a bunch of stuff in it. I've just done simple stuff. I've done book apps. I've worked with a bunch of different APIs. I've just done a bunch of bullshit, just kind of all over the place. A lot of university projects, like things like that. Nothing insane or goated or anything, but I've worked on a bunch of different things. So anyway, let's jump through this. Keep track of true potential. Man, flip happens when they swap. Oh, I'm from Russia. Oh shit. Okay, dude. 4:44 a.m. Fair enough, bro. That's pretty late, but I like your streams. They're kind of vibey. Thank you, bro. I appreciate that, dude. And for Linux Plus, you try by making a simple chip 8 emulator for a Game Boy emulator. Okay, I appreciate that. Definitely will. I'm gonna be looking over some smart pointers today after this stream, so just trying to get familiar with all that stuff. Even though I sit here for 15 minutes. Yeah, appreciate you stopping by, OS Quivel. Thank you for hanging out, dude. Appreciate the love, dude. So thank you. Teach you about computer architecture and generally low-level stuff. Yes, bro. I agree. Andre. Thank you. I will. It was cool, Andre. Everyone's chirping, dude. Howdy from Alabama, dude. Let's go, dude. Roll Tide, bro. Roll Tide. What's up, dude? Good to meet you. We forget to save again. I might be down in Alabama in a few months, bro. There's I want to go to one of the Alabama football games, dude, in Tuscaloosa. One of my old school's playing there. Eastern Illinois at Alabama, dude. Tuscaloosa. Let's go, bro. Okay, so when we swap here, what are we going to look at, right? So we're going to look at our curve-min. Our curve max is going to become 2, and our curve min is going to be 6. So our curve min will be, what, -12 will be is what we're looking at. What do you mean? I might say it. What experience do you have in like this sphere? I do not know at IT. Is that a question for me, OS Quivel, or is that someone different? I'm going to assume it's probably for me, but I just want to make sure that you're talking to me. I don't know if you're talking to someone else in the chat. Me, I just graduated high school. I am self-taught. Let's go, Andre. Go to, dude. Self-taught. I do this for fun. I enjoy CS. Okay. -12. So what are we doing here? Swapping this. So... Kermin is 2, so that's not going to work. Our Kerm max is going to be 6 times -2. Okay. I think I understand kind of what's going on here. It's for Andre. Just keep grinding, Leetcoding, bro. Thanks, man. Okay, I understand what's going on here, so I'm pretty good with this. I've been streaming for about an hour and a half, so I think I'm probably gonna end the stream here. So, appreciate you guys watching. I'm gonna go work on learning C++ and stuff. So, for the last couple hours, I'm gonna be up. So, I am graduated in May with CPE degree. Also currently looking for a job too. Yeah, bro, it's tough out there, bro. You ain't no private software. Don't know what that means, but thank you guys for the love. Probably gonna end it here, so I'll be back tomorrow streaming again for another hour, probably doing some Leetcode problems, probably do the daily problem and everything again. So appreciate you guys, and I'll see you tomorrow.